Right, so to answer the question of where this guy is discontinuous, you are looking at where you have to pick up your pencil. So in order to draw this graph, you would obviously have to pick up your pencil at -1. So it's going to be discontinuous at -1. Also, to continue tracing the graph, you would have to pick up your pencil at 0. So it would be discontinuous at x is equal to 0. If I continue to trace the graph, I would have to pick up my pencil at 1 in order to get up to this filled-in circle, so it would be discontinuous at 1. And then I could continue to draw the graph, trace the graph without picking up my pencil for the remainder of the time. So we have 3 discontinuities here. Now, they're asking us what part of the formal definition breaks down. So remember, the formal definition is that the function is equal to the limit. So you want to know that the function exists, you want to know that the limit exists, and the third thing is that you want them to be equal. So you want the limit to be equal to the function. So if you look at -1 here, you have a function value. F of -1 would be equal to this value, which they are showing as 3. So f of -1 exists, it's equal to 3. So part 1 does not break down. Part 2, though, does break down. So the condition that is not being satisfied here is condition 2, and that is because the limit is a DNE. Now, you might ask, why is the limit a DNE? The reason why it's a DNE is because of the jump that is in the graph. So this would be a jump discontinuity. All right, now if we look at x is equal to 0, again, we have to pick up our pencil, so that tells us that we have a discontinuity. The function existing would not hold here, and that is because if you look at x is equal to 0, you have this shooting up of the graph, which would be a vertical asymptote. So it's never actually hitting x is equal to 0. And here at x is equal to 0, you have an open circle. So f of 0 does not exist, and that is because of the open circle. Moreover, the limit doesn't exist, and that is because the limit from the left would be positive infinity, but the limit from the right would be this value, which they're identifying as 3. So the limit doesn't exist because you're jumping across, so both the function and the limit do not exist, and therefore the third condition is obviously not satisfied. So here, as far as what type of discontinuity it is, it would be an infinite discontinuity because you are going up towards infinity. All right, now for x is equal to 1, let's talk about that. At x is equal to 1, do we have a function definition? F of 1 would be defined as that filled in circle, which looks like on the graph as 2. The second condition would be the limit. Does the limit exist? And in this case, our limit does exist because as we go into 1 from the left, we would go towards this open circle, which is identified as a y value of 1. And as we go in from the right, we would go towards this open circle, which is identified as a y value of 1. So our limit from both sides would be equal to 1. So condition 1 satisfied, condition 2 is satisfied. What's not satisfied is that the limit does not equal the function value at 1, because the limit is equal to 1, the function value is equal to 2. So the concern here is that condition 3 is failing us. Now, what type of discontinuity do we have there? It is not a jump in the graph. It is not blowing out to infinity. Because of this hole that we have in the graph, this would be a removable discontinuity. Okay? So just to make it crystal clear, again, the concern for number 1 as far as what condition was not satisfied was condition 2 was not satisfied. The concern for x is equal to 0, every condition was not satisfied. 1, 2, and of course 3 was also not satisfied. And then the concern for the very last one, x is equal to 1, was that the third condition was not satisfied.